Okay, so this is Madas Maths Synoptic paper A, and on question 1 what we are given is two coordinates A and B, and we are asked to show that the perpendicular bisector of the line AB is given by this equation here. So the first thing I would do for a question like this is to make a rough sketch of the coordinates. So this doesn't have to be to scale. So let's say points A and B are something like that. And what we're trying to find, so the perpendicular bisector is the line that's perpendicular to AB and passes through the midpoint of AB. So we have the midpoint of AB there. So the midpoint of AB, I'll just call that one point N. You can label that anything you want, and I'll call this line L. So the first thing you'd want to find here then is the midpoint of AB. And the midpoint of AB is not that difficult to find. So that's going to be, so I'll just say coordinates of N is going to be, so to find the midpoint, you add the x coordinates, divide by 2, and then add the y coordinates and divide by 2. So this is going to be -1 add 7 divided by 2, and then 5 add 11 divided by 2 for the y coordinates. So if we simplify this, this gives us 3, 8. Okay, so we have the midpoint, we know the coordinates of N. What we now need is a way to find the gradient of L. So to find the gradient of L, we first find the gradient of AB, and then we can use that to find, and then the negative reciprocal of that will give you the gradient of L. So I'm just going to first say m of AB. So the gradient of AB, that's just going to be y2 minus y1. So 11 take away 5 divided by x2 minus x1. So the change in x, 7 minus 1. So if you calculate this, either put it into a calculator or just work it out, gives you 6 over 8, which then simplifies to 3 over 4. So that's the gradient of the line AB. Now what we need is the gradient of line L, and that is simply going to be the negative reciprocal. So I'll say m of L is the negative reciprocal of this, because this line is perpendicular to AB. So that's going to be -4 over 3. So now we have everything we need to be able to find the equation of this line. So we can either use at this point y equals mx plus c, or I'm going to use y minus y1 equals mx minus x1. So if we plug the values in, so we have y minus y1, the y coordinate is 8. The gradient, we need to make sure we use the gradient of L and not the gradient of AB. So that's going to be -4 over 3 times x minus x1, which is the x coordinate, that's 3. Okay, so at this point, most of the time we might just expand the brackets and move the 8 to the other side and give the answer in y equals mx plus c form. But here, because we are trying to show that the equation can be written like this, I think rather than expanding the bracket, the better thing to do is to just multiply this by 3 first, just to get rid of that fraction. So if you times by 3, we get 3y minus 24 is equal to -4 times x minus 3. We can then expand the brackets on the right hand side, so that's -4x add 12. And then when we rearrange this, so add the 4x to the left hand side, so we have 4x add 3y, and then adding 24 to both sides, so that gives you 12 plus 24 gives you 36. Okay, so that's this equation here. Okay, on part B of this question, we are now told that the perpendicular bisector of AB crosses the coordinate axis at the points P and Q. So I've got an exact plot of this here, but again, you could just do this with a sketch. So the points P and Q, it doesn't really say whether P is on the x-axis or the y-axis, so it doesn't really matter which way around we mark this. So I'll just assume that it crosses the x-axis at point P and the y-axis at point Q. You could mark this the other way around, that will not make a difference here. So it then says find the area of triangle OPQ. So we are trying to find the area of this triangle. Right? So what we need to find here first is the coordinates of P and Q. So the equation of this blue line, so the perpendicular bisector, we already showed in part A that it's given by 4x plus 3y is equal to 36. Now, if you have an equation in this form, the ax plus by equals c form, the easiest way to find the points where the line crosses the x and y axis is to simply substitute x equals 0 and y equals 0. So to find where it crosses the y-axis, I'm just going to put x is equal to 0. So this would give you, so if x equals 0, this equation would become 4 times 0, which is nothing. So I don't really need to write this part, but you can if you would like. So 4 times 0 plus 3y is equal to 36. So the 4 times 0 just is 0. So this gives you 36 divided by 3 gives you y equals 12. So we know that this coordinate here is going to, so the y-intercept is at 12. And similarly, to find where it crosses the x-axis, so I'll just do that on this side here. So to find where it crosses the x-axis, you just put y is equal to 0. So if I say y equals 0, this equation will now become 3x plus 4x plus 3 times 0. 3 times 0 is 0, so that's equal to 36, and that gives you x is equal to 9. So it crosses the x-axis, so the point that I marked P here, that x coordinate is 9. So in terms of finding the area of this triangle, so now it's just half base times height. So we have a triangle like this. So this is our origin O. That's point P, so this has a length of 9 because that x coordinate is 9. This is point Q, and that distance there is equal to 12 because the y coordinate there is 12. So we can then finally say that the area of OPQ, so area of triangle OPQ is equal to half times base times height. So if you work this out on the calculator if you need to, 9 times 6, that would give you 54.